In this lecture, we shall be discussing about the shielding multiplier. So shielding multiplier is basically given in this section 4.3 of AS1170 and part 2. The page number that on which it is given is page number 32. So if you refer to this particular page, if we first of all want to understand what exactly we mean by the shielding multiplier, just to, I just want to show you this photo here. So in this picture, you can see that how, many buildings are surrounded by other buildings also. So as a practical engineering judgment, what we can see here is that let us suppose if we are, let us say, if we are talking about this particular building here at the center. So, as in common engineering judgment, we can also say that let us suppose if a particular, wind is flowing from this particular direction, or if wind is flowing from this particular direction, then we can say that, either this building or in this case from this direction, this building may, provide some restriction or provide some obstruction to the easy flow of the wind. It is not like that full wind shall be acting with full intensity on the, this particular yellow highlighted building. So that is a basic concept of shielding multiplier that we do consider that at the time of extreme wind or as per the surrounding environment, there may be a shielding factor available for buildings. Now the first rule, if you're talking about the shielding multiplier, the first rule is that it shall be valid for for structures with height less than or equal to 25 meter only. So that is the important restriction that is given in the code itself, that this MS multiplier shall be applicable if the height of the structure is less than or equal to 25 meter, or else the MS, that is shielding multiplier, has to be taken as 1 only. That is, we won't be considering any kind of shielding multiplier for that particular case. So as a simple engineering judgment, we can say that shielding may be provided by upward bending, and it shall not be provided by trees or vegetation. So let us say, if this is a building that we are going to construct, and let us say there is a tree here. So we won't say that, the shielding, or we can say the shielding multiplier is provided with this particular tree. We won't say that. So trees or greens, that shall not provide, any kind of shielding to the building structure, because it may happen that practically, that tree may not be there after like 4 to 5 years or 10 years, or due to any other restrictions also. So that is why it is always recommended to avoid trees and to consider buildings only, and that too, if you're the building that you're going to design, the height is less than or equal to 25 meter. So on the bottom, we can see the some practical example here. So in this practical example, this is the building on which we do need to calculate the shielding. So this is the the main building under the question, and these are the surrounding buildings. So first of all, if we talk, let us say we are talking about the building in the blue color. So this building as an we can say as a shielding, it exceeds the building being shielded, because if we're talking about this particular building height, so this is this height. So the height is getting exceeded for this particular building. So we can see that we can consider this building as a in the form of shielding factor. Now, can we consider this building also, that is a building in orange also? So this is not a shielding building. This is not a shielding building. That is, we cannot consider its effect in calculation of the shielding factor, that is MS. Why we cannot consider that? Because the average slope, the slope here, that is greater than or equal to 2. So in this particular case, slope is greater than or equal to 0.2, and elevation is also less than the building being shielded. So in here, this is the height of the, you can say, structure, and this is the this is much lower here. So that is why we cannot consider this building as in the form of a shielding multiplier. Now if we're talking about this particular building, this building shall also not be a shielding building. Why it shall not be a shielding building? Because its own height, that is this particular height, this is less than h, assuming that this is the h that we are right now talking about. So in here, this height is less than this particular height, so this is also not a shielding building. And whether this building is also shielding building, this is also not a shielding building, as the distance of the, we can say, this particular building from the building under the question, that is greater than 20 h. So that is why, we can say that this is also not a shielding building. So the only shielding building here that we can consider this particular building in blue, because its height is less than is greater than, or its elevation is greater than the building under the question. This shall not be there because we can say that the slope is we can say greater than or equal to 0.2, and in this particular case the building height itself is less than this particular building height, and in this case the distance is greater than or equal to 20 h, or 20 times the height of the building under the question. So that is a basic difference or basic consideration, after which we can consider the we can say shielding effect. So if we're talking about the shielding multiplier, we have to calculate a parameter known as the shielding parameter. So what exactly is the shielding parameter? Shielding parameter S. So we shall be calculating a basic example also of this. So shielding multiplier S is equal to L time L sub S divided by square root of H sub S and B sub S. Now, if we're talking about the LS means so see, just to give you a brief preview, we are talking about the calculation of shielding parameter here. So after, we calculate the shielding parameter, we find out the value of the shielding multiplier, that is MS, that shall be, given as an input in the calculation of VSIT beta. Now, in here, as a just we can see here that if shielding parameter is less than or equal to 1.5, shielding multiplier shall be 0.7. That is, we shall be drastically reducing the wind speed. And if shielding multiplier is greater than or equal to 12, we won't be, we can say decreasing the wind speed, and we shall be having shielding multiplier value MS as 1 only. And for intermediate values, we can use a linear interpolation also. Now, I have shown you the formula also, that is LS divided by square root of HS and BS. Now, what exactly is the LS? LS means the average spacing of the building. And that is again given by another equation, that is H time 10 upon NS plus 5. Now, HS is basically, if you're talking about HS, the one parameter that we were discussing here. So this particular HS, when we are talking about this, HS is equal to average roof height of shielding buildings. Average roof height of shielding buildings. So we can say here that, let us suppose if we are having 3 to 4 buildings of 10 meter, 5 meter, 6 meter and 8 meter, we can just simply average, sum them and divide by 4. That is, we can simply find out the average. If we are talking about the BS, the one that, we are seeing here, BS is basically average breadth of the shielding building normal to the wind stream. Average breadth of shielding buildings. So, if we are having the considered calculation of our BS, so if wind is flowing from this direction, this shall be BS. Or we can say BS1 plus BS2 divided by 2. So that, we can do, but this is the, breadth of the building that we do need to consider for calculation of the value of the S. Now, what exactly is meant by LS? LS is equal to H, and in here, basically H is the average roof height above the ground of the structure being shielded. So this is the height of the structure on which we have to calculate the, we can say, shielding parameter. And NS is basically number of upwind shielding building within a 45-degree sector of radius 20 h and with HS greater than or equal to h. So in here we have already seen here that what the importance of 20 h parameter and the importance of the height. So when we're talking about this NS parameter, that is this particular parameter here. So NS is basically number of building. So in here, let us as an example, NS is equal to 1 because this is the only building that is shielding the building under the question. So for example, for this particular case, we can take NS1. And h is basically this parameter here, that is average roof height of the structure. That is our question, that we do need to calculate the shielding parameter. And ls, hs and bs, all of them are average. ls is basically, we can say, average spacing of shielding building. That is calculated by this particular formula. ls is average spacing of shielding buildings. So let us say we have 5 or buildings or 6 buildings or whatever number of buildings we have. With this particular equation, we can find out the average spacing of shielding buildings. And if we're talking about the HS is basically the average roof height, and BS is the average breadth of the shielding buildings. So this is how we can calculate the shielding parameter S. And after calculating the shielding parameter, the question does not finish. We have to accordingly calculate the shielding multiplier MS, or we can just simply interpolate the values also. So let us say if our shielding multiplier is 4.5, in that case our MS, that is shielding multiplier, shall be 0.85. So this is how we can do the interpolation also. Now, just as an example, I just want to show you a typical example of how we can calculate the shielding multiplier. So let us say average roof height of the structure being shielded, and that is the height of the building under the question. Let us say it is 15 meters. This is the building on which we do need to calculate the value of the MS. So average roof height of the structure being shielded, let us say it is 15 meters. Number of upwind shielding buildings, let us say it is 3 only. Average spacing of shielding buildings, what we can do here is that we can just simply multiply, or we can say that it is the value of the LS. Now LS, if we want to calculate, that is equal to 15, 10 divided by number of shielding buildings, that is 3 plus 5. So this is the value of the, we can say, LS. So if we multiply this, it comes out to be approximately 125 meter only. So average spacing, this is rounded off. So average spacing LS is equal to 125 meter. Average roof height of the shielding buildings, let us say it is 10 meters. Average breadth of the shielding buildings normal to wind, let us say it is 5 meter. So the shielding parameter S is equal to LS, that is this value that we have calculated here, that is 125, divided by square root of 10 into 5. So if we solve this equation, our shielding parameter S comes out to be 17.7. So as per the table that is on the left, if our shielding parameter S is greater than or equal to 12, so in that case MS has to be taken as 1. So in this example, we can see that our shielding multiplier can be simply taken as 1. So this was just a basic, we can say, example also, and a basic equation and basic calculation how we can calculate the shielding parameter. So I shall simply revise all the concepts that we have learned in simple word. In reality, we can just if we're talking about the shielding parameter, or we can say shielding multiplier MS. So that first of all, if our building height is less than or equal to 25 meter, in that case only we can consider the shielding multiplier. Second thing that we do need to understand is that we have to first of all calculate the shielding parameter, and on the basis of that we can calculate the shielding multiplier. To calculate the shielding parameter S, the equation that needs to be used is this particular equation, that is S is equal to LS divided by square root of HS and BS. So this is the equation that needs to be considered. So LS here, LS is basically, we can say, the average spacing of shielding building, which is again calculated with the help of this particular equation. That is LS is equal to H multiplied with 10 upon NS plus 5. So after calculating the value of LS, we can just simply calculate the value of shielding parameter S, and on the basis shielding parameter we can just calculate the value of the shielding multiplier, either directly or by interpolation. So after that, that equation shall be, we can say, used to calculate the value of the V SIT beta, or we can say V design theta also eventually, or we can say wind pressure eventually. So that is the, we can say, basic or you can say introduction to the calculation of the shielding multiplier MS.